So what is TinyML, right? Many things, including low power machine learning apps. They're running on embedded systems, typically without operating system. You can run them with, like if you have slightly more powerful embedded systems, like you have 4 to 8 gigabytes, you can run it on RTOS and some other lower, compute consuming operating systems like FreeRTOS, which is real-time operating systems and such. And like I said, you don't have to connect to internet or the cloud. So cloud connectivity and internet connectivity is optional. It makes the compute affordable because you have the entire board in your hand with the application running on it is within $10 to $20, sometimes $50. And your cell phone typically state of the art, like for example, Pixel 7 is about $700 today. So 10 to 15 times lower cost. And of course, it fosters privacy because your data is not leaving anywhere, and it has low latency because there may or may not be a network. So you don't have to rely on a remote server to get connected and provide the throughput and the latency that the application requires. So why TinyML, right? I'll give you one example. I have several, but because of the interest of time, let's talk about image sensors, right? We are in 2022, and number of image sensors that were produced in 2022 is about 10 billion in 1 year. And given that one image sensor average life is about 3 years, in the world there are approximately 25 billion image sensors. Now, if you compare that to world population, which is about 8 billion today, on an average, you can quickly calculate that on an average, one person, including a baby, is carrying about 3 image sensors. And so those 3 image sensors, the kind of data those sensors are producing is of the order of 10 to power 20 bytes per second. So 1 followed by 20 zeros. So that's called 100 exabytes per second. Now, why that bandwidth is interesting is because if you look at the entire internet bandwidth today, the entire bandwidth of all countries combined, all the digital data that's floating around the earth is about 45 to 80 gigabytes per second, which is of the order of 10 to power 10 bytes per second or 10 to power 11. And so we are 10 to power 9 to 10 to power 10 bytes per second away just to support these image sensors. And that would take another 10 to 20 years for us to create the kind of networks that are required to support all these sensors and their data being stored in the remote server. So the problem we have is we don't have enough bandwidth. Even if you throw the entire internet bandwidth on these sensors, you're not doing enough. You won't do good next year, 5 years from now, and maybe 10 years from now. So there has to be other solutions, and one of the solutions is that you consume the data that is produced on these image sensors on the board itself. You don't communicate, you don't transport that data back to the remote server. And that is why TinyML starts to shine in areas where you don't have connectivity, or you need to process that image sensors data frame by frame on a tiny sensor where you don't require connectivity. We are actually forced to use some of these applications without connectivity. So this is one, and I can go on and talk about other reasons why TinyML is shining and expected to outshine some of the prevalent technologies like cloud and such.